I should have asked. Everybody got this? If not, I'll loan you another copy, but nice if you have it. Y'all got it? Y'all got it? I didn't quite finish the lesson off from last day. Cleo, you got it okay? Where we are? I could have finished off the lesson, but I could tell in the final 10 minutes I talked too much and I was losing you. So today we're going to finish this off, and then I got a bunch of kind of reinforcement practice stuff you can work with. So delete pause here. Electrons are the special thing. Electrons are weird. If you ask Mr. Perugia, our chemistry teacher, what's an electron? We really can't give you a good explanation of what one is. We can give you a model. This year, we're going to treat electrons like they're tiny dots moving around an atom. That's nonsense. Do you know how big an electron is? This is going to blow your mind. As far as we know, electrons have no space. They don't take up any room in the universe. They exist. They do things. But either they're smaller than any technology that we've come up with to measure their size, or they have no size whatsoever. How can something exist and have no size? Electrons are weird. This is quantum physics, and things just get weird when you go into quantum physics. For now, what do you need to know in Science 9? Electrons occupy special regions, and we call them, can you underline this, energy levels? Or the word I'm going to ask you for on a test begins with the letter S. Yep. The region that they occupy accounts for 99.99% of the volume of an atom. I showed you a video last day trying to convey to you how small a nucleus is compared to the atom itself. And I think the analogy that they gave you was if an atom was the size of a football stadium, the nucleus would be the size of a tiny marble. You'd be able to see it, but just barely. Nucleus is small. Protons and neutrons take up very little room. Electrons, the shells, take up a lot of room. Each electron occupies only one whole energy level at a time. I have to fix a misconception. So it is not like a planet orbits around a star. And so I'd like you to write the word orbits and then do me a favor, put a line through it to say we're not going to use that word. It was in fashion for a while, but then people started thinking, oh, they're tiny dots that move around the nucleus the same way the Earth moves around the sun. Electrons are not tiny dots. We're going to use that as a metaphor, as a model, but they're not that either, Paige. They're weird. You want the best definition of what an electron is? It's the answer to a one-page long equation. Is it Heisenberg's equation? I think it's Heisenberg's equation. A better analogy, still wrong, Helia, but a better analogy, instead of thinking it was a tiny dot, would be to think of it more like a spread out cloud of negative charge that exists in the whole region all at once. But Amy, it's actually even way stranger than that. If you're bored, do a YouTube search for quantum physics, and you'll dive down a black hole. That will also explain how black holes work. But you'll dive down this YouTube black hole. The more you learn, the weirder quantum physics is. Be afraid. But it's cool. Put your pencils down, look up. So the first thing you're working on is section 1.3 homework. As always, this time I did attach the answers. Good habit to get into before you turn in the homework. Mark it yourself, do your corrections, and then hand it in. I'm not going to make you, but that would be a clever way to kind of learn from your mistakes, and I'm really big on learning from your mistakes. This is from the textbooks, pages 28 to 33. Then, the second handout that I gave you, this one does not have the answers attached. This is called Atomic Theory, the Contributors. If you look at your atomic theory notes that we just finished, and if you look in the textbook on page, let me pause for a second. You can also, if you want to try and figure out what blanks are going in here, you can start looking at page 28. Can all of you open your textbook to page 28? Or if you only have one textbook at the table, put it between you, please. Okay. Your textbook is pretty well laid out. I think page 28 looks kind of like this. Words to know, that's a good hint. This is where I pick my matching vocabulary, fill in the blank things from your test. So that's all right. But you really want to start to learn to study from a textbook. How do you do that? This is going to sound terrible, but you do not read the entire thing. No one does. No one does. Do me a favor, Gabe, on the sheet that I gave you called Atomic Theory, the Contributors, what are the first two words? Read me the first kind of phrase, please, from the very beginning. Stop. That word, Greek philosophers, this paragraph says, today we know everything. Skip. The second paragraph, Greek philosophers, you know what? I'll bet you to the answer to that is in that paragraph. This is how I've taught myself to study. You look at the first sentence of a paragraph, and you look at headings. For example, I think on the sheet on Atomic Theory, the Contributors, I think I'm asking you questions about John Dalton, am I not? If you look at that sheet, I would probably jump straight to this heading, Jim, and start reading down here. I'll bet you the answers are here. I will absolutely help you with this, and we will go over the answers to Atomic Theory, the Contributors on Wednesday. So this is your homework for the weekend. Get section 1.3 done. If you finish that one, you can hand it in because I attached the answers. Mark it yourself. The Atomic Theory, the Contributors, since I didn't attach the answers, it's nice that we can go over them in class. We'll go over them Wednesday. Any questions? You got half an hour. Get her done. No homework for the long weekend.